Oh, it really wasn't. All right, I think it's recording now because it's still flashing. If not, I guess I'll Skype Sam. Oh, I hope we're recording, Sam.
Hi, Sam.
Okay, so review of everything you learned in physics in 90 minutes flat. Maybe 80 because they cut 10 minutes on my class.
Really?
Okay, so displacement. What is the difference between displacement and distance?
Displacement is everywhere, and then you get there, and it's just the distance. It doesn't matter how you get there.
Okay, so...
Oh, do we have to turn the test?
Yes, we do.
Okay, so this purple line is going from point A to point B, and the black line is going from point A to point B, except it should be straight. One more time.
I made it.
So, which one is a longer distance?
The
Purple.
The purple line. Which one is a bigger displacement?
Black. They're the same. Well, the same, yeah.
Same displacement. Because displacement just means the straight line distance between 2 points. Distance is like how far. And which one's the vector quantity, which one's the scalar quantity?
The displacement is a vector.
Displacement is a vector quantity. So, if I go from here 5 meters down the road and then back 5 meters down the road, what is the distance I traveled?
5 meters.
And back.
Oh.
10 meters.
10 meters. And what is my displacement?
0.
0 meters. Newton's first law is
For every like action
force.
Force there's an equal and opposite.
For every force there's an equal and opposite force. Newton's second law.
That's the one with the equation, right?
Mm-hmm.
Can't remember.
You must know this equation.
Oh,
Gosh, this is gonna be so hard. Do we have a study guide or no?
No,
This is
you
your
are
study
writing
guide.
your study guide right now.
Okay, so what was the first question?
Displacement versus distance. Displacement is a vector quantity.
Place
You can have a video copy of this.
is a vector quantity?
Yes, distance isn't. Displacement
Isn't a vector.
Displacement is a vector.
Newton's first law?
Distance is not a vector.
What's Newton's second law?
Yeah, that's the question.
Just
I don't know.
I can't spell distance. Look in the book. I think I can.
Okay.
Newton's second law. Anybody? F equals
Oh, MC, MA.
ma. Force
I
is
knew
equal
there
to
was an M
mass
in
times
there.
acceleration.
Isn't
Newton's second
a
law.
vector. Okay, so
Newton's third law.
wait, are you actually doing like all the questions on the test?
Pretty much.
Okay.
So
Wait,
take
but I
good
thought there was
note.
just 10 like
Newton's
problems
law.
on
10
it.
problems and some definitions.
I really hope I do good on this. If I just study this, I'll do good, right?
Yes. Newton's third law.
Newton's third law. Just look at the board.
Oh, we got it wrong. Newton's first
it's
law.
not even there.
What we said for Newton's first law is Newton's third law.
Oh.
For every force, there's an equal and opposite force. Is Newton's third law. What's
First.
Newton's first law?
Give me a second.
You said the first law was what?
Oh,
An
an object
object
in
tends to
at
stay in
rest.
motion.
Yeah, okay.
Unless acted on
Said it
outside
too
force.
fast.
Okay, that's half of it. An
Couldn't
object
keep up.
remains in motion if it's in motion, unless it's acted upon by an outside force, or
An object that's at rest tends to stay at rest unless acted on by an opposite force.
yes, that's Newton's first law.
What's
Newton's
the
third
actual
law.
definition?
An object at rest remains at rest, or an object in motion remains in motion unless they're acted upon by an outside force. The law of conservation of momentum.
Hold on! Going too fast.
This is the prizes.
So what's this one?
Remain.
The law of conservation of momentum.
This is okay. So what was
look
the
at
first
that
law?
today.
I couldn't remember.
That's what the pendulum.
We're all
three.
writing stuff.
Yeah, okay. Just remember to make sure you know Newton's 3 laws.
That's the pendulum, right?
Unless
The
acted
Object in motion stays.
Everything obeys the law of conservation of
But
momentum.
that's like the main one they had in that chapter. Because I was looking at the labs.
Alright, what's the next one? Law of what?
Equal opposites.
The law of conservation of momentum. I will even write them myself so that I can't go too fast.
Okay. So the first law is object in motion stays in motion. Second law is F equals ma, which means
Force
Force.
is equal to mass times acceleration.
yeah. That's I was gonna say equals.
Now put
Oh, you look very cowgirl.
They said to dress up with like.
so what is the law of conservation of momentum? It's pretty easy. All the laws of conservations of things are pretty similar.
That momentum is conserved unless
Just like
acted on
Newton's-
by a different
An
outside force.
Yeah, momentum is always conserved, and if a system is, what's that word say?
Momentum.
Momentum in a system is conserved unless it is acted upon by an outside force. Okay, simple harmonic motion. What is simple harmonic motion?
Object or motion that's in a line or one-dimensional.
It can be.
The,
You can have simple harmonic motion that's.
doesn't it stay in like it goes to the same?
Everybody.
Isn't there like a band called something harmonic?
Yes, so as it passes the same point over and over.
So it could be in a circle, right?
Well, yes, and that would be uniform circular motion. The simple harmonic motion, a type of that, uniform circular motion, will be our next topic. So let's stick with the straight line, sort of mass spring, pendulum sort of guys. What is true about a spring, a mass spring system?
It always. One second.
What does the period depend on?
Isn't it the same no matter how far you stretch it?
Yes, so period does not depend on how far you stretch it, which we'd call what?
Displacement.
Maybe amplitude?
Yeah.
Okay, so for a mass spring system, period does not depend on amplitude. So it has simple harmonic motion because no matter how you stretch a spring, its period is constant. Depends on the spring constant, right? T equals
K.
spring constant over...
M. Right? Isn't it T equals K?
Yeah. Now,
'Cause I
how
remember
about...
you saying that
Do we
a
need
lot
to
on that
know
test.
that equation? T.
I remember there's
Right.
one test where we used that.
And then
equation
how about
like
a
1,000
pendulum?
times.
Andrew, is that K over M?
What
Yes.
does the motion of a pendulum,
What's
period of a
SH?
pendulum, not depend on?
Simple harmonic motion. What's UCM stand for?
Uniform
circular
circular
motion.
motion.
We haven't gotten there yet. What does the period of a pendulum not depend on?
Like initially, how far you bring it back?
No.
Well,
it,
what matters in a pendulum is it's only going to exhibit simple harmonic motion if you displace at a small angle. So you must displace the pendulum only a small angle, not greater than like 20 degrees from the equivalence point, the center. But the period of a pendulum doesn't depend on the mass on the end of the pendulum. Okay, if I swing a golf ball or a brick, as long as the string is the same length, the period's the same on a pendulum. Okay, if I put my 12-year-old in one swing and my 5-year-old in the other swing, then as long as there's no outside force, their period is the same. Their mass doesn't matter, even though she's 3 times his size. I think he's 6, so, oops. So period of a pendulum does not depend on mass. Hello.
Hi. Can I leave this for you?
Yes, thanks. So another type of motion we have is uniform circular motion. So remember, that's the lab where we swung the thing around in a circle, right? Anyone know the equation for that?
Oh, duh.
There's an R in there.
What's UCM stand for again?
Uniform
circular
circular
motion.
motion.
Uniform circular motion. Okay, so if we have uniform circular motion, then we have this. If we're talking about a planet orbiting, then we have right. We have an R squared in that one. Anybody want to tell me?
Hold on.
I think so.
I wouldn't know.
Is
You
that
better know
G?
next week.
Hold on.
I put my
Yes, it's R squared.
You're pretty much giving us like all the equations that we're gonna need and everything.
Indeed.
We just
Okay.
need to memorize this whole thing.
Yes, that's the
No,
point
just
of
memorize
today.
the back of the
If
book.
I get 100, I will cry myself to sleep every
Pay
night.
attention. What does uniform circular motion look like? This thing is what?
Circular ring.
Okay, it's moving in a circle. So when you have something moving in a circle,
Speed is constant.
okay, yes, you have constant speed, but can you have constant velocity?
No.
No.
Why?
On
Changing
occasion.
directions.
Okay, velocity is a vector. So you can't have constant velocity when you're moving in a circle because the direction is constantly changing. What is the direction of your velocity vector? Let's say this circle is going that way.
Isn't it like, would it be like, if you're up top, it'd be straight out?
Your velocity vector is tangent to the circle in the direction it's traveling. And how about your force vector?
Down.
Inward.
Towards the
Straight
center.
towards the
Towards
center of
the
the
center.
circle is your force vector. And how about your acceleration vector?
Doesn't it go inward too?
It's right along the force vector, right toward the center of the circle. So in uniform circular motion, you have a constant speed. Your velocity is changing only because of the change in direction, and your force and acceleration vectors point toward the center of the circle. Let's talk about, after you write that down, we'll go back to pendula and springs real quick.
Miss North. I just laid out. What was tangent to the circle?
Velocity vector.
Oh, sorry.
Well, the speed
No turtles.
the velocity vector, because the direction of velocity is tangent to the circle at that moment, but it's always changing because it's always moving. So when you have a pendulum, do I have a pendulum? Anything that could be a pendulum.
The camera.
Okay, so I have my pendulum here. Where is its kinetic energy maximum?
Right at the bottom.
Okay, kinetic energy is maximum
Right there.
at the equivalence point, the equilibrium point. Where is potential energy maximum? At the amplitude. Because where is velocity maximum?
The equilibrium point.
Here. Equilibrium point, velocity is maximum. Where is velocity 0?
At the amplitude.
At the 2 amplitudes. Where is, what's the other thing I want to ask? Kinetic energy, potential energy. Force, where is the force it's experiencing maximum?
Would that be at the amplitude?
Yes, force is maximum at the amplitude. And force is really, it's not experiencing any force, it's just continuing on because of kinetic energy right here. So, how about a mass spring system? Where is your kinetic energy maximum?
Where it's equilibrium.
Equilibrium point. Where is potential energy maximum?
At the amplitude.
The amplitude. Where is speed maximum?
That would be at the equilibrium.
Speed is maximum at equilibrium point. Where is speed 0?
At the amplitude.
Both amplitudes, because it turns around at both amplitudes. It has to stop and turn around. let's see, where is the force experienced by the mass at the end of the spring maximum?
Like the amplitude?
At both amplitudes, equal and opposite forces. What causes the spring to oscillate? What force tries to bring the mass back to the equilibrium point?
Restoring.
Restoring force. Let's see. What's the law of reflection? This is like lenses and mirrors. Law of reflection. SAT question. Josh got this.
Oh yeah.
The angle of incidence is equal to law
The
of
other one.
reflection. The angle of incidence equals the angle of reflection is the law of reflection. Okay, so have you all done your quarterly tests?
No. Were we supposed to?
Yes, you need to do quarterly tests to review for the final.
Like, when are they due?
They're not due. Just have your mom sign off when you take your final that you completed them and checked them yourself. Now that you've turned in Module 16 tests, you have free access to the answer book. You can check your quarterly tests yourself. Make sure you get them right. If you get one wrong, learn from it. So, I'll draw them then. If you have a,
Equal angle.
let's see,
So,
distance versus
What?
time graph.
That's how I learned.
Distance, displacement versus in meters versus.
How do you draw that?
Wait, you just changed.
How do you draw that? You draw the.
Okay, so if I have this graph, what is the slope of the line? What quantity is the slope of the line going to give me? This is a position versus time graph. Position versus time. So what's the slope? The y-axis divided by the x-axis. What's the slope of a position versus time graph? What's meters per second?
Wait.
Velocity.
I don't know if that's a trick question.
Slope equal, it is if you,
Think too hard.
yeah. Okay, so the slope of a position versus time graph is velocity. Area under the curve, if you've taken calculus, is acceleration. But you don't need to worry about that. That'll be the first page of your calculus book if you have a good calculus book. And it was the first page of your physics book too, I think. So what if you have a velocity versus time graph? What is the slope?
Acceleration?
Yep, because velocity is meters per second and time is in seconds. If you have y, meters per second, divided by seconds, then you get meters per second squared, which is acceleration. So the slope of a velocity versus time graph is acceleration. The slope of a position versus time graph is velocity. Important to know. Let's see. If something is traveling at a constant velocity, what is its acceleration?
Zero.
Constant velocity means acceleration is 0.
He's looking at my skin tone.
Velocity
So
versus.
the M.
Oh.
S.
Velocity divided by time equals acceleration.
Slope of velocity versus time is acceleration. So if something's traveling at a constant velocity, its acceleration is 0. What if speed is constant? What is acceleration?
Should be the same, right?
What's tricky about speed? What's the
So
difference
that's-
between speed and velocity?
Their velocity is a vector.
But speed isn't. So can you tell acceleration from just speed?
No.
No, because you don't know if the direction is changing. To make sure I'm using vectors, or if I'm not, then don't worry about them. If acceleration is constant, what is velocity doing?
Increasing or decreasing is changing.
If acceleration is constant, what is velocity doing?
Increasing?
It's, it's changing because it could be accelerating the like.
Acceleration is constant.
Wait.
Velocity would be increasing.
Someone yelling at
It'd be
someone?
changing. Like, because you can
Decreasing.
You can, like, if you're applying the brakes, it's
No, say
accelerating the
something
opposite
different.
direction.
So as long as it's accelerating constantly, velocity could be changing.
Yeah.
Or if acceleration is constantly zero, velocity could be.
Oh.
A constant acceleration, just like gravity, right, could be a constantly increasing velocity. A constant acceleration, like brakes, could be constantly decreasing velocity. A constantly zero acceleration could be a constant velocity. So just because acceleration is constant, you don't necessarily know what velocity is doing. You need to know more about the acceleration. Okay? So as long as acceleration is constant but not zero, then you're either speeding up or slowing down. So if I throw my little pen up in the air, then where is, let's see, let's say I throw my pen up with a velocity vector of 2.0 meters per second. Then what is the velocity when I catch it?
2 meters per second down.
2.0 meters per second down. The point at which you throw it, and when it gets exactly back to that point, it has an equal and opposite velocity. How about where is, let's see, what is acceleration on the pen? If it goes straight up, straight down.
8 meters per second.
9.8 meters per second squared,
Yeah.
down. Acceleration is constant. It's constantly 9.8 meters per second squared straight down, no matter where the pen is. Okay, the acceleration is constant. Acceleration due to gravity is constant. It's constantly 9.8 meters per second squared down. Okay, velocity is continuously changing. So where is velocity zero?
The top.
Right when it changes direction, velocity is zero. Is the acceleration anything but 9.8 meters per second squared down anywhere?
You have to accelerate to throw it.
Okay, when it leaves my hand, it has zero acceleration from my hand anymore.
Okay.
So, yes, it accelerates, but the problem like starts when it leaves my hand and stops the instant before it hits my hand. So it has no outside force once the problem starts. So that is sort of tricky, yeah. Let's see. Where is its velocity maximum?
At the top.
Velocity is zero at the top. It
Oh,
turned
right
around.
Where, the point right where you started off.
Or equal
Right-
and
Right where you
opposite.
catch
Right
it.
where we catch
Right. The moment that it leaves my hand and the moment right before it hits my hand, the velocities are maximum, equal and opposite, but maximum. This pen, let's say I throw it, which I won't. And let's say it travels in a straight line with a zero acceleration, because once it leaves my hand, nothing's accelerating it, right? So it's going to go in a straight line. We're ignoring air resistance. Is it in an equilibrium situation?
Wait, are we counting gravity?
We're counting just the x-axis of the
Oh,
state of the pen,
Like
If there's nothing acting on it,
right?
if
it
we
should
were.
stay the same.
Yeah.
Okay, so we've got a pen that's going on at a constant velocity, zero acceleration in a straight line. So what kind of equilibrium is that?
Dynamic.
It's dynamic because it's moving.
Translational? Is
Yes. So you have to have two words, dynamic translational equilibrium. Okay, you're always going to have two words. One of them is going to be one of these two. It has to be one or the other. Dynamic means it's moving, static means it's stationary. So this pen is in static translational equilibrium. It's not moving. And then you're going to have translational or rotational equilibrium. Obviously, a straight line motion would be translational equilibrium. Say something that's in uniform circular motion, would that be in a state of equilibrium?
Yeah. Be dynamic rotational.
Okay, as long as what? What is the key thing that has to be true for rotational equilibrium?
Constant speed.
Okay, the sum of all torques has to be 0. Sum of all torques has to be 0 for rotational equilibrium. But if the sum of all torques is 0 and it's rotating, then it's in dynamic rotational equilibrium. How about a seesaw? A seesaw rotates on an axis, right? So here's a seesaw. So let's say I have this seesaw and it is not moving like this. What kind of equilibrium is it in?
Static rotation?
Static rotational equilibrium. It's holding still, but it could rotate, but it isn't. So static rotational equilibrium. If I had a seesaw, what would the equation be that I would use?
I don't know.
Okay, here's a problem you want to check out. If I have a mass on a seesaw and a mass on the other side, maybe another mass somewhere, what equation would that be?
Is there a R in there?
The lever arm, the length of the lever arm, we call radius.
I said R.
Right, yeah, it is actually R,
okay.
so radius is R in this case. So your seesaw, the sum of all of the perpendicular forces on one side times the length of the lever arm, which is R, is going to equal the sum on the other side. So the sum of all torques on one side, which is F perpendicular times R, so force. So if I give you, say, kilograms, you want to convert that to newtons. How would I do that?
Times it by the gravity.
Yes. So kilograms times gravity will be newtons. So your force times the length of your lever arm. So the sum on one side of a seesaw would equal the sum on the other side of the seesaw. Let's see. This question.
Their camera's about to
So
die.
might want to review a seesaw problem.
Camera's about to die.
Oh, good thing we have that other battery. We'll be back, Sam.
What?